Hello everyone, welcome to the course Geotechnical Engineering 2. So, in this module number 5 and lecture number 2, we will be discussing on the load carrying capacity of soils. Okay? So, let us look at the course outline once again in the case of deep foundations. So, initially we have understood the introduction to the pile foundation, and in today's lecture we will be covering the load carrying capacity. Later we will be understanding some of the other tests related to this load carrying capacity, that is the pile load test, as well as a terminology known as the efficiency of a particular pile. And we will be understanding the settlements in case of these deep foundations, as well as there is a terminology known as this negative skin friction. We will be learning about this. And finally, in this course we will be learning in deep foundations the other type, that is the well foundation. Okay? Now, coming to the previous lecture. So, we have understood what do we mean by deep foundation. That means the depth of any foundation when it is very large compared to the width. In such case, it is known as the deep foundation, and these are generally not constructed by open excavations as we usually do in case of shallow foundations. Okay? Apart from that, why do we need to use these deep foundations, or when do we use these deep foundations? That means when the depth to width ratio is generally greater than or equal to 4, we may go for deep foundation, and when the bearing capacity of the soil, that means the strength of the soil is very low, in such case also we will go for deep foundations. When there is non availability of proper stratum along the shallow depths, then also we go for this deep foundations. And when the heavy loads are coming from the superstructure onto this foundation, and in such case when it is not economically feasible, okay, to construct a shallow foundation to bury such large loads, then also we may go for this deep foundation. Okay. So, in any of these aspects we may prefer the deep foundation. Clear? Now, so we have understood the different types of deep foundations as well in our previous lecture, where it is classified as pile foundation or pier foundation or caissons or well foundations as well as sheet piles, out of which in the previous class we have understood some of the different types. However, we will understand about the foundations in the upcoming lectures. And here one thing you need to understand, the caissons and well foundations are very heavier in section and they are sunk to the required depth. That means these are very heavier and these have to be sunk to the required depth. Okay, only for caissons and well foundations. Let us now discuss the today's lecture, that is load carrying capacity. So, what do we mean by this load carrying capacity or load bearing capacity? So, the ultimate load bearing capacity of the pile is actually defined as the maximum load. It is defined as the maximum load which can be carried by any pile. Okay, it is the maximum load carried by any pile and at which the pile continues to sink without further increase in the load. That means, if I am giving any external load, because of this external load the pile will sink and there is no influence of any external load or increase in load on this. Okay. Such type of load that is carried by the pile is known as the ultimate bearing capacity of the pile. That means, if we have to understand this in more detail, the ultimate load which the pile can carry without any failure. Okay? Now, so what do we mean by the allowable load then, and how do we determine it? That also we need to understand. Here the allowable load is nothing but the safe load that the pile can carry. Okay, it is the allowable load or the safe load that the pile can carry safely and which can be determined from the ultimate load by using a suitable safety factor. That means, we can determine this allowable load from the obtained ultimate load using a factor of safety. Okay. Now, let us now discuss the different factors that are affecting the pile capacity. So, if you look at here, the surrounding soil may influence the capacity of this pile that it can take, and then the installation technique, like whether it is driven or board pile that is actually constructed. And then we have the method of construction is another factor that is influencing, whether it is a precast one or it is cast in site, that also is an important factor. And then we have the location of the pile in a group. That means, if we are constructing n number of piles at a certain location itself, So, the location of the pile in that particular group is also an influence, and the spacing of the piles in the group, at what spacing we are providing these piles, okay, that is also an important factor. And then the symmetry of the group, okay, whether we are actually providing any axial symmetry to this group of piles or not, that is also an important factor in pile capacity. Later, the shape of the pile group and the location of the pile cap. That means, if you consider any set of group of piles, that means the load that is coming from the superstructure has to be distributed to the group of piles. So, the load has to be distributed in a single way. So, obviously, then we need to construct a slab sort of arrangement known as pile cap to this set of piles, where the load is distributed to this pile cap and then from the pile cap to this entire set of piles. Okay. So, that location of the pile cap, at what depth we are placing, that is also an important factor. Okay. And lastly, the drainage conditions in the soil. Okay. So, the drainage conditions indicate whether the soil is in saturated state or fully saturated state or submerged state or partially saturated state, or say it is in dry state. Okay. Now, let us discuss the methods of determining the load carrying capacity. So, the load carrying capacity can be determined by the following methods, that is using a dynamic formula or a static formula, or by a pile load test, or by penetration test. Okay. So, using any of these four methods, we may determine the load carrying capacity of a particular pile. So, either by dynamic formula or static formula or pile load test as well as penetration test. Clear? Let us discuss one by one more in detail. The dynamic formula. So, coming to the dynamic formula, so it is useful for estimation of this pile capacity by dynamic means. So, the dynamic formula is completely based on the assumption that the entire kinetic energy that is delivered by using a hammer, whenever we are using some external force, there will be some kinetic energy developed. So, this kinetic energy delivered by this hammer during the driving operation is actually considered equal to the work done in penetration. Okay, it is considered equal to the work done in penetrating the pile through the soil. So, that means the kinetic energy delivered is equal to the work done by the driving force for penetration of the pile. So, this is given by, the kinetic energy is given by WH into eta H, that is equals to R into S plus energy loss. So, here where W is the weight of the hammer in kilonewton and H is the height of fall of the hammer and eta H is the efficiency of the hammer and R is the pile resistance taken generally equal to QU, that is the ultimate bearing capacity, and finally S is the penetration of the pile per blow, that means for individual blow what is the penetration that is occurring. So, this is the dynamic formula. And then coming to the other one, there are different dynamic formulas available. So, you may refer to either engineering news record formula or Haley's formula or Danish formula. So, now let us look at the engineer's new record formula, where it is given by QA is equals to WH by F into S plus C, where QA is the allowable load in kg here. Okay. QA is the allowable load in kg and W is the weight of this hammer and H is the height of fall in mm. Okay. And F is the factor of safety, usually taken in this case as 6.0, and S is the settlement, okay, considered as the final settlement per blow, it is also known as the set, and C is the empirical constant that is considered. Okay. Now, so looking at the Haley's formula, it is given by taking into consideration the various energy losses, which is given as QU equal to WH into eta H by S plus C by 2, okay, where Q is the ultimate load on the pile and W is the weight of the hammer, H is the height of fall of the hammer in mm, and then eta H is the efficiency of the hammer. Here eta H is the efficiency of hammer. So, we may use different types of hammers here. One is a drop hammer or single acting hammer or a double acting hammer. So, depending upon the type of hammer, the efficiency of the hammer must be considered. In case of drop hammer, it is 100%, and single acting hammer it is 75 to 85%, and in case of double acting hammer it is considered 85%. And C is the elastic compression here, okay, and then S is the average settlement that is considered per blow. Now, the other one is the Danish formula. So, it is given by Qu is equals to W into H into eta H by S plus S naught by 2, okay, where S naught here is the elastic compression of the pile. It is similar to the previous equation, but the only difference is S naught is considered, that is elastic compression of the pile, and it is obtained using this particular equation, that is root over 2 eta H into WHL by S plus S naught by 2. Okay. Now, so where L is the length of the pile and A is the area of cross section of the pile. So, coming to the static formula. So, in case of static formula, the ultimate load carrying capacity is considered as the sum of the end bearing resistance of this particular pile as well as the resistance of the skin friction. Okay. So, it is given by Qu equal to Qp plus Qs, that is Qp is the end bearing resistance and Qs is the resistance of skin friction, which in detail is considered as Qp into Ap plus Fs into As. Okay. We will look at what are these terms individually. So, here this capital Qp is the end bearing resistance as I have stated, and small qp is nothing but the unit end bearing resistance. That means, if you consider a particular pile at this, say this is a ground level, okay, and along this particular direction there is a pile driven up to a certain depth. Let us say this is a hard rock, and up to this level this pile has been driven. Okay. So, here Qp is the unit end bearing resistance. That means, at this particular region the ultimate resistance is determined here. Okay. And Ap is the area at that base. That means, the area of this particular pile at the base is considered Ap. And Qs is the skin friction resistance. That means, when it is driven through a particular type of soil, obviously what will happen? There will be some resistance offered along the surface. So, this resistance is offered along this particular surface in the opposite direction, since it is driven downwards. Okay. So, such resistance is known as the frictional resistance. Okay. So, it is given by unit skin friction, and this entire surface area, okay, which is being driven is nothing but As. Clear? So, in such way, by obtaining this we can obtain the value of Qu, okay, the ultimate bearing capacity of this particular pile. Okay. Now, so coming to the pile load test. Okay. So, these are generally used for estimating the pile capacity and is conducted with the help of a pile load test. Okay. Using this particular pile load test, we will obtain the ultimate bearing capacity of a particular pile, and this method is one of the most reliable method in practical case. And this is generally driven and then loaded up to failure. That means, a pile for testing is generally driven into the soil, okay, up to a certain limit by increasing of load, and it is tested up to failure. And then the ultimate capacity is related to the ultimate load, okay, or the load at which the settlement does not exceed the permissible limit. Okay. So, whatever permissible limit that we are considering, until then if the load that we are providing for driving this particular pile make sure that the settlement does not exceed the permissible limit considered. Okay. So, now coming to the other one, that is the penetration test. We have understood the penetration test in soil exploration as well. So, the pile capacity can be determined from this penetration test by the standard in situ test conducted in the site itself. And there are certain empirical formulas used to determine the point resistance and the shaft resistance from the standard penetration number n. Okay. So, I have listed here some of the assignment questions as usually, kindly go through them. and in the upcoming lecture we will be discussing on the static method for a driven pile in case of sands as well as corrosive soil, say clay. Okay. So, that is it for today. I hope you have understood very well. Thank you very much. Have a nice day.